Okay, we previously looked at vectors. Now we're going to look at adding and subtracting vectors. So there's a couple ways we can do vectors. We can place them head to tail, tip to tail, and we can use graphically. We can find what's called the vector sum, and that's how we can add vectors. So how this looks. Let's say you got to go 5 paces north, 3 paces east. If we draw a straight line from any of those two vectors, that's going to be how we add the vectors. So again, we go tip to tail. From the vector A and vector B, vector C then will be our net displacement to that point. That's the sum. It can be done graphically, which is really easy. To add 2 or more vectors, you just keep adding them. So we go here, and then we add this one. And then we just draw a straight line from the beginning to the end, and that is going to be our resultant. Again, graphically doing vectors is okay as long as you're careful with your angles and everything like that. Vectors are unchanged if moved to another location. So as long as I know this and my angle, I can take this vector and move it to anywhere on my coordinate plane. And I can use that then to move into positions where I can add them up. So in order to place them to the head to tail, it may be necessary to move arrows that represent them. So like for example, A and B. A is here, B is here. There's my resultant. If I were to do them in the other order and put B, then put A, you can see that my resultant is going to stay the same. Again, the order of adding vectors does not matter. So now consider the vectors A and B. Which of the other 4 vectors is the sum of A and B? So we just very quickly, we want to take A and B and see what our answer is going to be. And I can look at this, and I first can see A and B together gives me C. So for sure C is one of my answers, right? Can anything else be? Well, let's change the order. Let's do B and then A. We get the same result, so therefore C is the only answer we can have. So C is my answer to the sum. So that's how we add them graphically, okay? It just depends how accurately you can draw, okay? You need a ruler and a protractor, and you have to have a scale. And then we just measure this and the angle, and we can find our resultant information. But this requires some work if you want to do it graphically, and you have to be very exact. The most precise way is to use components. And you must find the components of the vectors. You must find the x's and add them, okay, to find the sum. And then you got to do the same thing with the y components. And we'll show you how to do that here. So the sum of the x components gives the resultant x. So if I look at A and B, if I look at my XA and my XB, that will equal the total x for C. Same thing with the y. The A and the y and the AY and the BY will equal the CY. So adding the components will give you the resultant information using the equations that we used previously. And there's the math for that. We'll do a practice problem so you can see it better. So here we go. So we want to find this total displacement. We went 6 paces east and 3 paces north. And we want to up and to the right are both positive, so we got positive numbers. So I want to go 6 paces east, and I want to go 3 paces north, and I want to find this. Okay, we want to find the magnitude and direction. So we want to find the number and the angle. Now to find our resultant, we just use Pythagorean theorem. 6 squared plus 3 squared, and take the square root of that. So 6 squared is 36, 3 squared is 9. That adds up to 36 and 9, and we take the square root I get 3.35 meters as my C. Or paces, yeah, six paces. Each pace is 0.5 meters in length. I guess I should have included that. So if each pace is half, let's go back. My 6 paces then comes out to 3 meters, and this comes out to 1.5 meters. So 3 and 1.5 squared gives me 3.35 meters. So that's my resultant distance. 3.35 meters. Now to find my angle, just like before, inverse tangent of my y, 1.5, over my x, 3. And then when I math all that out, I get 26.6 degrees. And that's how I have my answer. 3.35 meters, 26.6 degrees northeast. Now subtracting vectors, all you do is whatever this other vector is that's you're subtracting from, you make it negative. Okay? And then we do everything else the same mathematically. We can subtract them graphically. So if B is going this way, and we want to subtract from it, then we just take it and go the opposite direction, because positive direction and negative direction, only thing that's different. So if A is this way, and B is this way, but I want to subtract, I got to take B and go the opposite direction, which makes my resultant go into a different quadrant.